Hi everyone, welcome to the first session of the physical chemistry, that is adsorption. Okay, I have some questions for you. Why some particles soaked on the charcoal surface are? How air filtrates separates the pollutants? S. This is because of the adsorption phenomenon. Myself Sumalata S, Assistant Professor from the Department of Chemistry, SKNG GFG College, Gangavati. In this session, we will going to explore the Langmuir adsorption isotherm. Let's begin the session. Adsorption. What is the mean by adsorption? Adsorption is the process where the molecules or atoms of a substance adhere to the surface of another substance. Okay, see here what happens, this adsorption is the surface phenomenon. Here molecules or the atoms of a one substance is going to accumulate on the surface of the other substance. Okay, the molecules or atoms which are going to be accumulate are called as adsorbate, and these are accumulate on the surface. That surface is termed as adsorbent. Okay, here, and we know that there are two phenomena. One is the absorption, other one is the adsorption. What is the difference between these two phenomena? Here, in case of absorption, what happens? The molecules or the atoms will penetrate into the bulk of the material. Okay, so this is the bulk phenomenon. Absorption is the, whereas this adsorption, here the molecules or atoms, these are accumulate only on the surface. So this is the surface phenomenon. Adsorption is the surface phenomenon. Okay, next our topic is Langmuir adsorption isotherm. What is this model describes? The Langmuir adsorption isotherm is a model that describes the equilibrium between the adsorbate, means the molecules which are going to accumulate are known as the adsorbate, and adsorbent systems, the molecules which are going to accumulate on the surface, that surface is termed as adsorbent. Okay, here in case of Langmuir adsorption isotherm, this describes the equilibrium between the adsorbate and adsorbent systems, particularly for monolayer adsorption on a homogeneous surface. It assumes that the adsorption occurs at specific identical sites on the surface, and there are no interactions between the adsorbed molecules. Okay, here in case of Langmuir adsorption isotherm, here what happens? There is a equilibrium between the adsorbate and the adsorbent systems, and this assumes the monolayer adsorption, means the adsorbates, means the molecules which are going to accumulate, those forms a single layer on the adsorbent surface, and this is on a homogeneous surface. What it means homogeneous? Means the adsorbent surface has a identical adsorption sites, means all the sites on the adsorbent is identical, that is termed as a homogeneous surface. Okay, and there is a equilibrium between the adsorbate and the adsorbent, means there is the state where the rate of adsorption equals to the rate of desorption. Means how many number of molecules are going to accumulate. Similarly, equal amount of molecules on the surface will going to desorbed. Means there is a desorption. Adsorption means accumulation. Desorption means removal of molecules from the surface. Okay, molecules leaving the surface. So there is a equilibrium. Okay, this is about the Langmuir adsorption isotherm. The model predicts that at the low pressures, okay, this is at the low pressures, the extent of adsorption increases linearly with the pressure, and at the high pressure it reaches a maximum surface coverage. What happens when we are in case of low pressure? The adsorption increases with the directly with the linearly with the pressure. Means as the pressure increases, the adsorption also increases, and ultimately at a particular value of pressure, this adsorption reaches to a maximum value. Okay, this is regarding the Langmuir adsorption isotherm. Next, assumptions of the Langmuir isotherm. What are the assumptions? The first one, he assumed in this isotherm, the Langmuir assumed that the surface is the homogeneous. Means the adsorbent surface has a fixed number of identical sites for the adsorption. Means the sites present on the adsorbent those are identical. That surface is termed as a homogeneous surface. Okay, next, second one is the he assumes for the monolayer adsorption. Means only one layer of adsorbate molecules can form on the surface. Means the adsorbate forms a single layer on the adsorbent surface. Okay, this is about the monolayer adsorption. There is no multi layers. In this case, only the single layer of adsorbates form on the surface of the adsorbent. Okay, and the third assumption is the no lateral interactions. Means adsorbed molecules do not interact with each other. Okay, fourth one is the dynamic equilibrium. Means there is a equilibrium between the adsorbate and the adsorbent systems. Means which means that the rate of adsorptions will equals to the rate of desorption at the equilibrium. Okay, these are the assumptions of the Langmuir isotherm. Okay, one is the homogeneous surface, second one is the monolayer adsorption, third one is the no lateral interactions between the adsorbed molecules, and there exists a dynamic equilibrium between the adsorbate and adsorbent substances. Okay, this is regarding the assumptions of the Langmuir isotherm. Okay, next, the Langmuir equation derived from these assumptions relates the surface coverage. Means how many number of adsorbed molecules will accumulate on the adsorbent. That is represented as surface coverage theta. Okay, theta is the fraction of adsorbed molecules accumulate on the adsorbent to the pressure P is given by the theta equals to Kp divided by 1 plus Kp. Okay, here theta is the fraction of the surface coverage and P is the pressure of the adsorbate gas. Okay, and K is the equilibrium constant for the adsorption. Okay, this is the expression for the Langmuir isotherm, and the plot of the Langmuir isotherm is given by the, okay, this is the theta, means the fraction of the molecule will going to accumulate on the adsorbent surface, that is represented as a theta, and this is theta is plotted against the pressure P. Okay, here what happens, while at the lower pressure this theta increases linearly with the pressure, means as the pressure increases the fraction of the theta also increases and reaches to a maximum value at a particular pressure, and this is the, after that this remains constant. Okay, this is the plot of the Langmuir adsorption isotherm. Okay, next, limitations. What are the limitations of the Langmuir adsorption isotherm? Here the first limitation is the, this assumes at the low pressure, means this model works at the lower pressure. The model is most accurate at low to the moderate pressures, as it assumes only the monolayer coverage, means at the low pressure the fraction of the molecule accumulate on the adsorbent will increases linearly with the pressure, but at a higher pressure it reaches to a maximum value, after that it remains constant. Okay, so this is one of the limitation. This applies to the only at the low pressures or the moderate pressures. And the second limitation is homogeneous surface assumption. Okay, what happens, the adsorbent molecules, it have the fixed number of identical sites available for the accumulation of adsorbent molecules. Okay, here, but in real case there is no such a homogeneous surfaces. Real surfaces are often heterogeneous with varying adsorption sites, so which can deviate from the Langmuir model. Okay, next, third one is there is no lateral interactions. The assumption of no interaction between the adsorbed molecules may not always hold true, especially at high surface coverage, means there exists some kind of interactions between the adsorbed molecules. Okay, and the last limitation is the, here this theory assumes the monolayer adsorption, means only single layer of adsorbed molecules accumulate on the adsorbent, means the model is not suitable for describing multilayer adsorption, which can occur at the higher pressures. Okay, these are the limitations of the Langmuir adsorption isotherm. Okay, from this session, from the end of this session, we came to understood that adsorption and Langmuir adsorption isotherm, assumptions of the Langmuir adsorption isotherm, and limitations of the Langmuir adsorption isotherm. Thank you for watching.